All right, looks good. So good morning again. Chad and Angela at HESCO, really appreciate you guys having me on again. Looking forward to talking to you this morning. Just a brief introduction in case you weren't tuned in to last week's webinar. My name is Stephen Hartsfeld, and I work for Rockwell Automation in our connected services business. I'm relatively new to Rockwell, but I've been involved with industrial automation in some way, shape, or form for the last 12 and a half years, focusing on industrial networks and security for about the last 4. Currently reside with my wife and our 2 sons in an even more fall-like central Pennsylvania than last week. In Hershey, PA, we had frost both mornings this past weekend. And today I'm going to talk to you about cybersecurity in industrial networks and what kind of threats exist today and things that you can do to mitigate the variety of risks that those threats present. So who are we as Rockwell Automation? Rockwell is a global company doing business in over 80 countries with 23,000 employees and almost $7 billion in annual sales. This makes Rockwell the largest company in the world dedicated to industrial automation. And we have been helping companies to deploy control networks for decades with the aim of bringing the connected enterprise to fruition. So in today's landscape, manufacturing companies are facing an array of challenges. Some of the big ones are the skills gap. Many of the most experienced personnel are reaching retirement age and taking with them valuable tribal knowledge that legacy plants have relied so heavily upon. So backfilling with younger folks is very challenging today, and without the necessary staffing, it's become difficult to meet your productivity goals. Inflexibility. So many manufacturing companies have been a little bit slower to adopt some of the risk management processes in the OT space. They often lack the tools that are necessary to manage their OT infrastructure effectively. And when I say OT, I'm referring to OT or operational technology, which is sort of the counterpart of IT or information technology. So OT refers to the plant floor. So they often lack the tools to manage that infrastructure effectively, and they struggle from having a glut of data sources, but an inability to transform that data into actionable information and knowledge about their processes. Convergence is a big challenge. It's very common that plants don't have a comprehensive asset inventory, so they struggle to manage life cycles and updates, and they can't protect what they don't know is there or can't see. So frequently we see firms struggling to integrate new technologies. Those might be non-industrial IoT technologies, but also manufacturing-focused software solutions, right? And finally, vulnerability, which is sort of what we came here to focus on during this conversation. Security in OT is very often an afterthought. The primary concern in OT is functionality, effectiveness, efficiency, and cost. And cybersecurity risk represents a hidden cost that can mount very quickly. Many plants are relying heavily on aging or even obsolete equipment that might no longer receive software or firmware updates to account for security vulnerabilities. And I come across this less and less as time goes on, but for a long time, plants didn't have any kind of security policy or procedures in place in the event a breach occurred. And because OT tends to be very static with machines and components expected to last decades, not years, it's a challenge to stay abreast of cybersecurity, which is highly dynamic, even by IT standards, where life cycles are much, much shorter. So you've certainly heard the phrase, follow the money. Well, in this case, you can see that money is the reason that cybersecurity has become such a concern in the OT space. In the last 2 years, some 53% of manufacturers have experienced a cyber breach in their facility, and that's just the number that's willing to admit it, right? Breaches over that span of time are estimated to have cost almost $12 billion, $12 billion with a B. And 2 big reasons are ones we just touched on, right? Legacy, unpatched infrastructure, and lack of competency in the space. The smart attackers understand that these environments are full of vulnerabilities that can bring entire facilities and even companies to their knees if properly exploited. And most OT environments are poorly documented. If you don't know what is connected in the environment, you can't effectively secure it. These are some of the most notable ICS-focused cyber campaigns over the last decade. By no means an exhaustive list. So going back to 2010, Stuxnet is undoubtedly the most infamous example of an ICS or industrial control system focused malware, which was used to successfully disable and in many cases destroy scores of Iranian uranium enrichment centrifuges that are located in a fully air-gapped network environment. Just a couple years later saw the appearance of Shamoon, a virus which destroyed some 80% of the IT infrastructure of a global energy company, all because the company's network architecture, both IT and OT, was completely flat and unsegmented. So once the attacker was inside, they had access to just about everything, and they could just run roughshod in their environment. And Shamoon set to work essentially bricking every computer it could get itself onto. The scale of this attack was so immense that we're talking tens of thousands of computers, that it briefly interrupted IT hardware supply chains across the globe because this company was spending millions and millions of dollars buying more computers and hard drives, actually sending an airplane around to different suppliers and factories, just getting their hands on anything they could get their hands on, so they could replace the IT infrastructure that had been damaged. Black energy later in the decade was targeted at critical infrastructure like the electric grid, and succeeded in knocking out power to millions of people. Many of us have heard in the news about WannaCry and NotPetya, both of which are ransomware that encrypts a system and demands a ransom to recover files, all while spreading aggressively throughout a company's networks. A notable difference between these two malwares is that while Petya, which NotPetya was intended to emulate, and Petya's predecessor WannaCry, is that WannaCry and Petya were actually trying to extort money from victims, while NotPetya was purely destructive. The Bitcoin wallet address where NotPetya victims were told to send their ransom payments was the same for every computer. Meaning there was no way to track payments in order to restore systems. I couldn't tell, all right, computer number 391 just paid me, so now I can unlock it. There was no way to do that. They were just trying to destroy as much of the infrastructure as they possibly could. Like Alfred from Batman said, right? Some men just want to watch the world burn. So understanding the types of attackers that we see in this ecosystem is important because it can help you to recognize what might be premium targets to these different groups. Hacktivists are hackers that try to use their skills to advance a particular political or social cause. An extreme environmental group might be an example, going after the fossil fuels industry. Your typical hacker or cyber criminal is just trying to extort money from victims, right? Insiders are a big concern as they're typically armed with network credentials, right? They can move through the system with relative impunity. They might be out to steal intellectual property for their own financial gain, or they might just be disgruntled and want to inflict damage on the company. Cyber espionage sounds like something that might be from a movie, but it is a very real threat where nation-state actors or even private companies are trying to steal trade secrets and intellectual property from private companies. Terrorist groups are very active in the cyber world, trying to sabotage things like critical infrastructure in order to sow fear and unrest. And to sabotage critical infrastructure over an enemy state. Now, one thing to take into account is the collateral effect of ransomware. Often cyber criminals will cast a very wide net with a ransomware attack, perhaps with phishing emails or any number of loosely targeted methods that can end up infecting and impacting companies and individuals who weren't even on the attacker's radar. They throw a bunch of stuff on the wall and see what sticks, and then try to squeeze as much Bitcoin out of victims as possible. And what's really revolutionary about ransomware is that it no longer matters whether or not a target has anything of value to the outside world. Right? Attackers know that your information and your systems are important to you and your company's ability to do business and make money. So if they can take that away from you, it doesn't matter if your special sauce is a proprietary uranium alloy or a secret blend of herbs and spices, right? You need your own information systems to continue to operate, to continue to manufacture product, and to continue to be profitable. So let's talk about ICS threat vectors. And threat vectors are just the means by which an attacker can exploit your systems. So one of the most common threat vectors that we see in the OT space is the network vector. Someone can get onto your network via either a wired or a wireless connection, perhaps even remotely. Oftentimes, these attacks are exploiting weaknesses in remote access portals that allow third parties into your network for one reason or another, for maintaining a particular system or for troubleshooting a particular machine, whatever the case may be. And a great example of this is the Target breach from 2013, where the Citadel malware was used to steal credentials from an HVAC contractor. So this allowed the attackers to remotely log into a Target HVAC system. It was basically the air conditioning system, which got them onto the network because Target's network was not properly segmented. From there, they took over servers and then exploited their point of sale system, including a file transfer protocol that they were using so that they could actually compromise point of sale systems that weren't connected to the internet. And that led them to the mother load, which was over 100 million credit and debit cards, all of which contained just 11 gigabytes of data. Estimated cost to Target was nearly $300 million. Mobile devices are common attack vectors because you carry them with you all the time. It's very difficult to maintain good hygiene, good network hygiene, good cyber hygiene on a mobile device because they bounce around between different cell towers. They bounce around between different Wi-Fi access points. There's a great chance that Bluetooth is turned on all the time. So there's tons of ways to compromise a phone. And once that happens, the attacker can probably find their way from your phone into your company's network. And especially if you leave your hotspot turned on, when you're connected to company Wi-Fi, anyone within range can access that network through your phone. They may not even be inside the building. And finally, good old-fashioned physical access is a huge one for manufacturing facilities. I can't tell you how many plants I've called on where I could just walk in a side door through the maintenance shop and through that right onto the shop floor with nothing more than a flathead screwdriver and the appearance that I knew what I was doing and I belong there. I could be dropping a USB stick into a PC or installing a cellular radio to give me direct access to a network from anywhere on the globe. So here's an example of some common ICS threat vectors. External adversaries are always trying to gain access to your system. This isn't a question or an if, they are trying to gain access. Now, this most often doesn't mean that there's someone snooping around your property at night or even a live person behind a computer. It's probably nothing more than a bot scouring the internet for vulnerable devices or sending out thousands of phishing emails. But it is happening. And in many cases, we see adversaries gaining access to IT networks and finding out then that they can gain access to the plant floor due to insufficient segmentation and firewalling. And then it's just a matter of figuring out how they're going to leverage this access for maximum damage, for maximum financial gain. And certainly we've seen direct attacks on OT networks, especially where infrastructure is the target. Whether somebody might be targeting a electrical grid or a power generation station or water wastewater. That's definitely a common attack vector. And then of course there's the sneaker net protocol, like we talked about earlier. A man walks up to a panel, opens it up, plugs into an open port or device, and can effectively leave behind a wide open backdoor that only he knows about. And finally, and perhaps most insidious, is the insider threat. Now, many times the insider threat is just an uneducated employee who doesn't follow the security policy or doesn't know the security policy, and that can open you up to attack. But the malicious insider is a real issue as well. Disgruntled employees, corporate spies, just plain greed, any number of things that you can think about that would drive someone to steal from their employer. Now, what we're talking about is cyber risk, but it's important to understand what we mean by risk. So the IEC defines risk as the combination of the probability of occurrence of harm and the severity of that harm. So it isn't just the likelihood of an event occurring or how easy it might be, but how bad it would be if that event happened. That also needs to play into your assessment of your cyber risk. So why is industrial security seemingly suffering so much? We talked earlier about OT environments being much more static with a longer life cycle. It's hard to go in and change things around and update them all the time when availability and uptime is your biggest concern, right? Because the cyber threat landscape is so dynamic, and so are many of the newest IIoT technologies or industrial Internet of Things technologies. We need our security solutions to be equally, if not more flexible and dynamic, but that can still handle protocols for data and the OT unique resources. This is one very important aspect of IT-OT convergence that we talk about all the time that will enable us to respond to new opportunities in the marketplace. Whether there are things like on-demand manufacturing or just-in-time manufacturing, or enabling remote monitoring or process organization and better management of risk, life cycles of productivity, visibility, you name it. Does anybody have any questions before we go on to sort of where we get started? Feel free to put them into the chat if anything comes up in the meantime. So all of these things are why we have to take a proactive approach to industrial cybersecurity. And that doesn't mean only being proactive in your preventative efforts, but also having plans and procedures in place for when attacks actually happen. We need to plan all the way across the attack continuum. So before an attack, we need to focus on identifying and protecting our assets. And that means keeping a detailed and up-to-date inventory of all of your OT network assets, managing patching, assessing your risk and your vulnerability, and then obviously deploying the security zone with countermeasures. So that we know when an attack is actually taking place, we need to have some method of real-time threat detection. So that should be a tool that is constantly sniffing network traffic, is looking for anything out of the ordinary, and alerting you as soon as it sees anything. It might involve an off-site SOC or a security operations center, or some way to do remote monitoring so that your watchdogs aren't swept up in the attack with everything else. Both during and after an attack, you need to have incident handling and response laid out and codified, so you're not trying to reinvent the wheel during a very stressful and high pressure situation like a cyber breach. You should be able to just refer back to the procedures and policies that you put in place. Many companies opt to hire a third party to handle their incident response and their recovery planning, which makes a lot of sense from a risk mitigation standpoint to do this, because you'll be leveraging someone who has experience doing just this. And most OT professionals' experience is in trying to make sure that it never happens in the first place. And of course, after the attack, having backup and recovery solutions in place will make it much faster and easier to get back to normal with as little interruption to production as possible. So our approach has to be both strategic and tactical. Let me silence my watch here. I apologize for that. There we go. So our approach has to be both strategic and tactical. Our strategy has to include the development of an OT cybersecurity program that dictates what we protect, how we protect it, and what we do if something bad happens, if and when something bad happens. So, best practice is not to formulate this program from scratch, but to use an existing industry framework like NIST, for example. It's important that you fully understand your business drivers and therefore your risk tolerances so that you can identify your highest risk targets. It's in order to understand the security gaps you need to fill, you have to conduct an assessment of your current state, which you can use to then create a remediation plan, which you handle in your tactical approach. So you have to fill the gaps you identified and prioritize while using validated designs and architectures like those in the CPWE, or the Converged Plant-Wide Ethernet that we talked about last week. And in many cases, it's a good idea to use pre-engineered infrastructure and software solutions where possible, so in order to hit your target, instead of custom developing every aspect of your solutions. So a common challenge that we see when we're trying to get funding or approval from executive leadership is that there is a perception that there's no business case to be made for addressing these risks. Now, I vehemently disagree with that, but once again, don't try to formulate your case on your own. The NIST Cybersecurity Framework, or CSF, provides a simplified approach for executive decisions in this space. Following their cycle, it's laid out of identify your assets, protect them, detect threats, respond according to plan, and then recover when the threat has been neutralized. We have to be sure to take a holistic view, right? Your organization's cybersecurity strategy should protect the assets it deems critical to successful operations. So, unfortunately, there aren't any shortcuts or simple solutions or silver bullet implementations to solve all of the cybersecurity vulnerabilities. So instead, you need to take a layered approach. So, we as a company follow the defense in depth approach within our own manufacturing systems, as well as those that we design and deploy for our customers, which is to say that we try to defend a system against any particular attack using several independent methods. So it's a layering tactic. Tactic that was actually conceived by the NSA, the National Security Agency, as a comprehensive approach to information and electronic security. So, defense in depth itself is originally a military strategy that seeks to delay rather than prevent the advance of an attacker by yielding space in order to buy time. So when you use a series of defenses together, such as firewalls, such as malware scanners, intrusion detection systems, encryption, integrity auditing solutions, you minimize your dependency on each one of those solutions and instead rely on a singular holistic security solution. You wouldn't You wouldn't rely, if you were trying to protect a high value location, VIP's house, you wouldn't just build a big wall and then do nothing else, right? You need to have layered defenses in place, right? Cameras, if somebody does get over the wall, cameras to see them, motion sensors, locks. You want to slow their advance so that you can take action before they can do any real damage, right? So defense in depth can be divided into 3 areas. So there's physical, technical, and administrative, which is very similar in nature to the Rockwell 3-pronged approach to safety that's outlined in the Safety Maturity Index. If you're familiar with that, you've got cultural or behaviors, compliance or procedural, and capital or technical. So defense in depth provides some redundancy in the event that a single security control fails or a vulnerability is exploited that can cover the aspects of behavioral, procedural, or technical security for the duration of a system's life cycle. So effective cybersecurity practices identify and execute these different layers, reducing the most frequent risks to industry. Now, when we're building out these measures, we definitely are going to be collaborating with our counterparts in traditional enterprise IT. And therefore, it's really important that we recognize the differing priorities in each environment so that we can address the different needs, right? So in the IT space, priority is the pervasiveness of data and the confidentiality of that data. Whereas in OT, the priority is on the reliability and integrity of the system. Architectures in OTs are typically proprietary in nature, and they're very task specific. So you have a machine or a component within a machine that does one particular task, right? Whereas in IT, the architectures are ubiquitous in nature, and they consist of multi-tiered systems because they're trying to encourage a high degree of accessibility, right? The IT endpoint, the typical IT endpoint is homogeneous. We probably can deploy the same PC throughout the architecture for workstation use, and we want them to be multi-purpose, right? We don't want to have one piece of equipment that we use to do email, and one piece of equipment that we use to access the internet, and one piece of equipment that we use to record financial transactions. One computer is intended to give you access to all these things. And they have a relatively short lifespan. So, if you were looking to make a purchase in the OT space and we told you that it was expected to only last 5 years, you probably would be pretty displeased with that. But that's considered a long lifespan for IT endpoints. So, on the flip side, OT endpoints are heterogeneous. There's a lot of different endpoints throughout the architecture, and they're task specific again, and they have much longer expected lifespans. And then the outcomes, finally, the outcomes in OT are physical, right? We're trying to make things. We're trying to move things around. We're trying to process things. Whereas our outcomes in the IT space are almost exclusively digital outcomes. So if we're taking a prescriptive approach to deploying cybersecurity measures in order to improve overall security posture, we can follow the NIST CSF or cybersecurity framework and its good, better, best models. So the first being a risk-informed cybersecurity strategy. So this is a recommended approach that improves your risk posture with more limited capital expenditure and a shortened implementation timeline. So these steps and services are not required to be completed in sequence. They can be executed and implemented in parallel at a global scale. And what we're referring to mainly is we want to establish our asset visibility. It's important that we conduct an asset inventory analysis so that we know what's out there. We want to determine what our risk posture is, conducting a risk assessment, reviewing our frameworks and our standards. And we want to develop a base cyber hygiene program. So that's going to include an anti-malware strategy. It's going to include migration from physical to virtual server infrastructures and compute infrastructures. Got to have an antivirus management measure in place. We've got to be patching our infrastructure OSs. And we got to have a backup and recovery plan. I hate to be that doom and gloom guy, but it's just a matter of time before there is some sort of a breach in just about every network. So we want to make sure that we can not only mitigate the damage that gets done or eliminate damage that gets done, but also, have a plan for how we're going to get things back up and running and back to normal. And then we got to make sure that our OT networks are ready. So we're going to conduct an assessment of our OT network infrastructure itself, and ensure that we've got segmentation in place by design of a logical network and an IDMZ. And an IDMZ is just an industrial demilitarized zone, which is a segmentation layer that exists in between IT and OT. We don't want to see what happened at that energy company where once someone gets in, because there's no segmentation, same with Target, they can just completely run roughshod and have access to everything, right? So the repeatable cyber strategy approach is a more foundational way to improve overall cybersecurity risk posture across the attack continuum. This is more of a moderate capital investment and defined operational expenditures or OPEX. So elements of a risk-informed cyber strategy that we talked about in the previous slide may need to be completed first prior to a deployment of a repeatable strategy. And the key tenets here, comprehensive installed base review, and that's hardware, that's software, that's networks. We need to start migrating legacy assets and those legacy proprietary network protocols. We've got to deploy that segmentation that we talked about. That's comprehensive IDMZ design and implementation. And we need to implement a secure remote access strategy. So almost every facility needs to have, at one point or another, the ability to give an outsider or a third party access to their systems for maintenance or for troubleshooting or for compliance, whatever the case may be. So we need to be able to provide that access in a secure manner. Secure endpoints are important. So endpoint security measures means having security in place at the actual endpoint itself, at the PC level, for example. If we don't have any sort of endpoint protection, it's a lot like building that wall around the house, but having nothing, no sort of measures once inside the wall to prevent damage, to prevent exploitation. And we talk about the trust model. We talk about endpoint security. So in a typical sort of a legacy network, you were assuming that someone inside the network was meant to be there because they had to have credentials in order to get access, whatever the case may be. A zero trust model focuses on endpoint protection. So it assumes nothing. It assumes that no one on the network can be trusted. And therefore, we have measures in place at the endpoint to protect all of the endpoints and to require, very specific and stringent authentication at the endpoint level. We want to deploy continuous threat detection as part of a repeatable cyber strategy. So we need to be able to know when there's something going on, when there's a threat present on our network. And that's part of a continuous risk management program. We need to be able to monitor and manage our OT environment. So that includes the OT network itself, the components that might be on that network, the data centers, the firewalls, and all of the applications. And we want to be able to monitor and manage that 24/7, 365. And we've got to have a disaster recovery plan. We've got to be able to deploy that and be able to adjust that disaster recovery plan in the event that something happens. And now, on top of that, the adaptive cyber strategy is a comprehensive OT cyber strategy that spans across the attack continuum, provides a multi-year approach and a blueprint to all the elements of a risk mitigation program. So this would include, detailed financial capital planning, cultural change management requirements, and workforce skills gap mitigation by providing real-time managed services. and elements of both the risk-informed cyber strategy we talked about first and the repeatable cyber strategy that we talked about in the previous slide may or will need to be completed prior to deployment of an adaptive strategy. So this is going to involve modernizing our installed base, right? We're migrating all of our legacy automation hardware, our software, our process systems, our platforms, including our physical infrastructures to virtual environments. It's implementing a detailed logical and physical network and IDMZ design. It's deploying a micro-segmentation strategy to break up that flat architecture so that we have not only smaller domains that can be exploited in the case of a breach, but smaller failure domains as well for when something goes wrong on our network that's not caused by a malicious actor. And then we need to expand to an integrated security management and administration program. So networks, firewalls, data centers, apps, threat detection platforms, antivirus, patch management. We want to be able to manage that all together. And we want to augment our workforce with a SOC, or with a security operations center that integrates the telemetry from our OT into our security operations, because it's part of the equation, right? And then we've got to have that incident response handling and plans developed. So we're creating and deploying specific workflows at this point for incident response, specific procedures, and have identified teams in place to increase the speed of our recovery. Okay. Any questions about those three? So what should we be doing tactically? Right. First, we have to deploy an OT network infrastructure that follows a framework like CPWE. And this diagram is an example of a CPWE architecture. This is a network framework. CPWE, or Converged Plant-Wide Ethernet, is a network framework we co-developed with Cisco that leverages industry standards and best practices, as well as Cisco's expertise in the network space and Rockwell's expertise in the manufacturing space. Okay, so we're using DMZ servers as a line of demarcation between IT and OT. We're using managed switch infrastructures. It's incredibly important in order to take advantage of the security features in addition to all of the other management capabilities and tools. Okay. We got to ensure that we have visibility and management tools in place, like FactoryTalk Network Manager, for example. We should strongly consider intrusion prevention and detection systems. We should be managing network access control with things like the Identity Services Engine from Cisco. And we should have measures in place to examine network traffic in real time. We need to maintain our asset inventory. We can use tools like FactoryTalk Asset Center and Clarity, which is a company that Rockwell partners with in this space. Disaster recovery is huge and can be handled with automatic backups and audit trails. And we need to be able to detect changes in our systems as well as report on those changes, and not just malicious changes, but also inadvertent changes done by insiders that can sort of create additional cybersecurity vulnerabilities if we don't have a handle on them. We have to pay attention to patching. We have seen too many attacks in recent years that could have been completely prevented with a sound patching program. And I understand that it is a much different set of challenges to maintain patching in an OT environment than it is patching, your regular enterprise IT. But Rockwell has some services and some assets in place to help with this. We maintain a patch qualification testing lab where that's all they do. As new OS patches come out and new application patches come out, we go through and validate them through a number of different architectures with different components, different products, so that we can sort of curate your Windows patches, right? That are catered specifically to Rockwell software and hardware. Okay. And then, managing authentication and authorization. So Windows Active Directory, we're following our authentication best practices. We could use things like FactoryTalk Security, which integrates into the Windows domain architecture. There's authentication and authorization services in FactoryTalk and in Studio 5000 that we can leverage. And we want to try to maintain that local and centralized audit trail so that we can tell what's happened, who did what, when they did it, et cetera, et cetera. And again, that secure remote access piece is very, very important, because at some point we're going to have to give a vendor or a third party or someone access to our systems. We have to handle that securely. And then antivirus and application whitelisting. So application whitelisting is essentially the opposite of a blacklist. Right? I'm sure you're familiar with the term a blacklist. It's a list of things or people or applications or whatever that are not allowed. A whitelist is a list that says only these applications are allowed to send data across my network. Anything else is going to be denied or disallowed. Okay, and we can do that, using Symantec, for example. Leveraging thin clients is also a really important and valuable way to shrink our attack surface, because all of the devices that get deployed throughout our OT architecture don't store the data on them. They're really are just giving you a window into a system that exists in a central location that makes it much easier to secure and control that one centralized infrastructure instead of having to do it 100 times out on the floor. It reduces our operators and anybody that can get access to a terminal. It reduces their access to the operating systems. It reduces their access to the physical machines, and it gives us some enhanced authentication capabilities as well. And then threat detection. So we are using our asset inventory that gets collected using a threat detection tool. We're creating a baseline that identifies what normal traffic looks like. We're alerting on deviations from this baseline. And then, of course, having that plan in place for incident response is so critical, because this is a very, very stressful time during a breach. I don't know if you've read the Wired article on the Maersk hack from a couple years ago. It's a fantastic article. I would absolutely recommend giving that a read. But they're telling stories of people literally sprinting through hallways, screaming at each other to unplug their computers, to shut things down. They're leaping over access control points because the badge readers don't work. So it's very chaotic. It's very hectic. It's very stressful. Make sure that we have a plan in place so that instead of panicking and just thinking of the first thing to do, we can refer to a procedure that'll help not only make sure that we have all of our bases covered and our I's dotted and our T's crossed, but we can sort of manage that stress level a little bit better. Now, one of the critical partnerships that we've developed as Rockwell over the past several years is one with a company called Clarity, which is an Israel-based cybersecurity company that specifically focuses on OT networks. And they have platforms for giving us visibility into our OT networks from a security standpoint, and also detecting those threats. And they also provide solutions for secure remote access as well. So they are monitoring traffic and creating a baseline for what's normal and what's anomalous, even if those anomalous actions are being carried out by an authenticated user, and collecting data in a variety of ways to really provide a robust threat detection platform. And one of the most common ways that we can help is through the network services subset of the connected services portfolio. And that includes, assessment, design, implementation, and management services. So we talked about throughout the last 45 minutes, we talked on numerous occasions about having a robust OT network in place and having segmentation in place and making sure that the infrastructure is ready for growth and ready for change, because if it's not, when we do those things, we're going to implement, or we're going to introduce additional threat vectors and additional cybersecurity risk. So, most commonly we start with network assessment and design services. A network assessment is simply an evaluation of the current state of a network that's, against the established industry framework or best practice. It's designed to provide an actionable and prioritized remediation plan. And then the design takes that one step further and provides a comprehensive blueprint to make a customer's desired future state a reality, both from a logical and a physical perspective. Our customer, you can take that design deliverable and give it to, bring it to a contractor for implementation, or they can engage with us, where we'll manage and oversee the entire implementation process, including procuring hardware, deploying the design, commissioning the system, delivering standardized documentation packages. And the same design and implementation capabilities also apply to IDMZ, that industrial demilitarized zone, that segmentation area that separates IT and OT, but still allows critical data to flow through in a secure and controlled manner. So we'll develop an IDMZ spec with rule sets defining what data flows are allowed through, select security hardware, provide a complete set of drawings, and we can also implement our IDMZ designs just as we do with our network designs. And once those systems are managed, we can also, or once those systems are implemented, we can also manage them for our customers, 24/7, 365. So monitoring, switch administration, warranty management, firmware upgrades, configuration changes when necessary. And these things are all very important, avoiding having obsolete equipment, avoiding having unpatched equipment, whether those are computers or switches, avoiding having, out-of-date firmware. This alleviates the need for you to maintain, a cross-functional team of IT/OT experts. We can provide that functionality to you on a predictable and on an OpEx basis. Right? And anything, all of these network services, we partner with HESCO, whether it's the network services on this screen, whether it's the Clarity, the secure remote access, the continuous threat detection. And of course, we can engage with you, HESCO can engage with you just on a conversation about this stuff. If you want to just talk it out a little bit further, we can certainly make that happen, because it's our goal to make you as effective as possible as a manufacturer. And if we're exposing ourselves to all sorts of risks, or being hacked or getting breached on a regular basis, we can't be effective. So, and it's going to cost a boatload of money to recover from those types of things. So we want to make sure that we make you as prepared as possible. So with that is what I have. Again, I would welcome any questions that you have. You can feel free to chat them in, or to speak up right now if you would like, or to contact myself, or to contact Chad at HESCO, and we'd be certainly more than happy to have a conversation about the different services and tools that we can provide to help you navigate. I know this can be a stressful and a confusing arena to work in, but we have experts in place, and we can certainly guide you through this process. So I thank you again for joining me. Have a couple minutes left on the hour, but that's all I have, and appreciate you guys' time. Appreciate you joining.
Thank you so much, Steve.
All right, if we don't have any questions coming in, I don't see any in the chat, then I think I'm going to shut down the recording, and we'll see you back here in a couple weeks. Hope you can join us then.
Great, thank you, Steve.
Anything else, Angela?
Nope, that's all. I think I see a chat here. Oh, thank you, Joseph.
All right, wonderful. Well, thank you very much.
All right, thank you all.